that px equals to x, px plus 1, so that it satisfies this equation here. Use this inequality to find the number of blue balls that Joe is most likely to draw. Sure. So, remember what I... Okay. How many people remember what Mr. Gunn says? But it's fine. Okay, I'm used to it. So this one is just a class, neighboring classes. Okay. So say you have px. Px is here. Px plus 1 is here. Okay, say this is like x plus 1. Okay. This is to compare which probability is higher. So this one tells you px plus 1 has a taller probability than px. Okay. So it's very useful when you use this to compare modal class, the most frequent class, because you just want to compare which neighboring classes is higher than the other one. Okay, so just so you know. So binomial distribution, we did this before. Okay, great. Now, I ask you to show this. So in other words, right, px plus 1, meaning instead of using n, they just want x lah. So if x amount of blue balls, then I want to compare with the neighboring x plus 1 here. Okay, so meaning we need to use this in terms of x. You just start doing that lor. I think it's fine, because the first part, if you already done it, the second part should be fine. This kind of question in the exam comes out, leave it to the last, assuming that you have time left in the exam. If you don't have time left in the exam, of course you leave it after the exam and try again. So yeah, so this is px equals to x less than px equals to x plus 1. Shouldn't be an issue. Comparing both neighboring classes. So then I'm going to put 20, my n sub as x, right? So this is 20 choose x, then times 15 choose 12 minus x, correct? Then the bottom is actually 35 choose 12. Then this is less than 20 choose x plus 1 times 15 choose 12 plus x plus 1 over 35. So everyone is happy because we could cancel the denominator. Life is great. Then we just need to simplify this factorial. Use the choose formula. This part here, remember that the formula for choose is actually in MF26. Okay, it's in MF26. Please remember NCR is n factorial r factorial n minus r factorial. Okay. I explained why it's like that. If you have why choose is n factorial r factorial n, but if you don't remember, it's okay. Just use m. Contrary to popular belief, the NCR is not under stats. It's under binomial expansion. Just right below the binomial expansion. The reason being is because it's actually a Pascal triangle. Pascal triangle. So just remember your NCR is here. Don't go looking at the stats part. You won't find NCR there. Okay? So this is NCR. Okay, then we're going to slowly do it. This one here. What you get is 20 factorial. X factorial. This is 20 minus x factorial. Multiplied by 15 factorial over 12 x factorial minus 15 minus 12 minus x. It's gonna be quite messed up, but you just carry it. Okay. There you go. So here, what I'll suggest is look at the like term. So for example, you see that this one here, x and x plus 1, they probably can be termed together, grouped together. 20 minus x, and this is 20, this is 19 minus x, likely together. Then 12 minus x and 11 minus x, they are together. Just make sure that they are, all these comes in pair. Make sure. Then you won't lose focus. Then even if when something goes wrong, you know what is wrong. Because if the rest are all pairs and you got one weird stuff, then you know that it's wrong. So what I'm gonna do is I'm gonna, of course, I'm gonna cancel this, the top one. Now, when you cancel, remember to put a 1 on top. Please don't leave it like you cancel, then it suddenly become numerator. As a denominator, it's just been denominator. So this is x factorial 20 minus x. 12 minus x. And then this will just 3 plus x. 1 over x plus 1. Then this is 19 minus x factorial. Then this is 11 minus x factorial. And 4 plus. Okay. So I bought the corresponding pair, just group them together. So like 4 plus x, the large one move on top, okay? So like you see between 3 plus x and 4 plus x, 4 plus x is obviously larger than 3 plus x, okay? So this one here, what I'm going to do is actually going to move this above here. Just move it above, okay? So just take note of that. And same thing, I'm just going to move around. This, you must understand that all these terms here are positive. All the terms here are positive, so it's okay to move about the, since all the factors are positive, you can just move, you can just cross multiply. Okay, so 4 plus x factorial is positive. All these are positive, so you can just multiply them, or you can just manipulate them like that. So I'm going to move this about. This is 3 plus x factorial. Then I have got a lot of things going on. X plus 1 factorial. I just moved the larger one on top. So this is 20. You don't have to follow my way, but usually you follow it because it's easier, okay? So I just moved the larger term on top so that you can see that this one here, you see? The larger one is on top. So the like 4 plus x factorial, 3 plus x, this one, this, and this one. The 4 plus x, I move it on top. Then the 12 minus x and 11. So I move it to the other side because 12 minus x is bigger. Then you have got 19 minus x and 12. So 12, 20. Then this one here got x and x. So just arrange accordingly. Alright. Factorial is very fun to play because factorial, just to give a recap, 10 factorial is 10 times 9 times 8 times 7 times 6. Whenever I want to stop, I can just put a factorial sign behind. Remember that. So it only makes sense. So it can also be 10 times 9 factorial. So whenever you minus 1, whenever you stop, just put an exclamation mark behind. Okay. So similarly, if you have got like, let's say you have n factorial, this is n times n minus 1, n minus 2, n minus 3. Let's say you want to stop here, you just put factorial. Okay, so that's the reason why you put the larger sign on top. Like, this is 4 plus x factorial. This is actually 4 plus x, 3 plus x factorial. Right? Then this one here is x plus 1 times x factorial minus 1. Okay, so that's why I left the larger one on top. So this is 4 plus x, 3 plus x factorial. This is x plus 1, x factorial. Then this is 3 plus x factorial, and this is x factorial. Then this same thing, this 20 minus x, this will be 19 minus x factorial here. This is 19 minus x factorial, and 12 minus x, 11 minus x factorial. Okay, like that. So you just split it up. Okay, you just take the bigger one, just split it up. Then after that, you can do your magic, which is to cancel, 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 and cancel. Okay, So this part here, what you left is 4 plus x plus 1. But they want bigger than x. Yeah, there you go. This one is x plus 1. Okay. How do I then find the mod? You just solve this inequality. How do you solve this inequality? I think just use GC lah. It's annoying, yeah. This is like what the heck, man. Solve this inequality. So for those of you who know that I like to use GC and solve, I don't really like it like that. I like it to be placed minus 20 minus x, 12 minus x bigger than less than 0. So I'm gonna find the x value which will satisfy this inequality. I don't want to solve it because it's 5 marks. If the first 4 doesn't cost me 4 marks, I don't even think that I want to do like. So I'm gonna just do this. I'm gonna put in x plus 1, x plus 4 minus of 20 minus x, 12 minus x. Okay, just solve this. Go to table. What I want is to see the first positive case. Nowadays, positive case very sensitive. So from GC, right, this is my x, my y1. This is most negative x. Am I right? Yeah, so most x, largest x, not one. Just x is equals to 6. So in other words, if you use this front one, so px, because we start out px is smaller than px equals to x plus 1, right? So this is px equals to 6 is less than px equals to 7. So hence the mode most likely okay, done. Because this is the mode here.